Hi all, so today we are going to see about drug metabolism. So the topics discussed here are done purely from the exam point of view, and if you want to read in detail, you can always refer to standard textbooks. So why is metabolism needed in the first place? As we all know very well, a drug should be lipophilic in order for it to cross membranes easily and produce a action. So once the drug has produced an action, the action of the drug needs to be terminated. In order to be uh, terminated, it should convert into a more hydrophilic substance. So this metabolism is a process which helps in conversion of lipophilic drug into a hydrophilic one and thereby helps in easy excretion. So this metabolism is also called as biotransformation. The end product of biotransformation is a more polar and inactive substance. This hydrophilic nature of the drug helps in easy excretion and drug action termination. At the end of metabolism, we can have biologically active metabolites or toxic metabolites as well. So, how is metabolism done? Metabolism is done with the help of some enzymes such as cytochrome P450 enzymes. These enzymes are not only involved in breaking or metabolizing the drug but also are involved in formation of some endogenous compounds such as production of steroid. So how are this classified? How are metabolism or metabolic reactions classified? So they are classified into phase 1 and phase 2 reactions. So they are classified into phase 1 reactions and phase 2 reactions. In these phase 1 reactions are also called as functionalization reactions. And where do the enzymes involved in phase 1 reaction can be found? They can be found in the endoplasmic reticulum. These phase 2 reactions are also called as biosynthetic or conjugation reactions. And the enzymes involved in phase 2 reactions are mainly found in the cytosol. So, at the organ level, where do this drug metabolism take place? It happens in liver, GI tract, kidney, and lungs. And the enzymes involved in biotransformation, apart from being seen in endoplasmic reticulum and cytosol, can also be found in mitochondria, nuclear envelope, and plasma membrane. So, the enzymes involved in metabolic reactions are broadly classified as cytochrome P450 enzymes and transferases. So here this table shows you a list of enzymes involved in metabolism and what kind of reactions they produce. So phase 1 oxygenases, we have cytochrome P450 which causes oxidation and dealkylation. Flavin ox containing monooxygenases, they produce oxidation. Epoxide hydrolases, they produce hydrolysis. In phase 2 transferases, they help in transferring this one group. For example, sulfotransferase, it helps to transfer sulfate group from this enzyme to the drug. UDP glucuronide transferase, it helps in addition of glucuronic acid to the drug. Glutathione S transferase helps in addition of glutathione. N-acetyl transferase helps in addition of acetyl group. Methyl transferase helps in addition of methyl group. The other enzymes which are involved in metabolic reactions are as follows: alcohol dehydrogenase, reduction of alcohol; aldehyde dehydrogenase, reduction of aldehydes; NADPH, quinone oxidoreductase, reduction of quinones. We have seen the enzymes involved in metabolism reactions. We'll go in detail about phase 1 reactions and phase 2 reaction. So what do phase 1 reactions do? They introduce or expose a functional group on the parent compound. So after introducing a functional group or exposing the functional group in the parent compound with help of reactions such as hydrolysis, it results in loss of pharmacological activity or it causes altered activity of the drug. So most of the drugs at the end of phase 1 becomes deactivated or uh, the effect of their action reduces. However, there are some drugs called as prodrugs, which are pharmacologically inactive. They get activated after metabolism. So one exception are these prodrugs. Generally, after phase 1 reactions, the effect of the drug reduces. But in case of prodrugs, it's opposite. The action of the drug begins after phase 1 reactions. And this prodrug's example is enalapril, which can be activated after phase 1 reaction of hydrolysis, results in a more active compound called as enalaprilat. So in phase 1 reactions, we have oxidative reactions and hydrolysis reactions. So in dealkylation, the examples of drugs undergoing N dealkylation are imipramine, diazepam, erythromycin, O dealkylation are codeine, indomethacin, dextromethorphan, aliphatic hydroxylation are tolbutamine, ibuprofen, phenobarbital, aromatic hydroxylation are phenytoin, propranolol, ethylene estradiol. So aromatic dehydroxylation, drugs undergoing these reactions are phenytoin, propranolol, ethylene estradiol, and N oxidation are chlorpheniramine, dapsone, meperidine, and S oxidation are cimetidine, chlorpromazine, thioridazine, deamination are diazepam and amphetamine. So drugs undergoing hydrolysis reactions are carbamazepine, procaine, aspirin, and lidocaine. So as the name suggests, for example, aliphatic hydroxylation, they cause hydroxylation of the aliphatic compounds. Similarly here, hydroxylation of the aromatic groups present in the drug. So coming to phase 2 reactions. So what does phase 2 reactions do? They will form a covalent linkage between functional group on parent compound or phase 1 metabolite and endogenously derived substance. So already we have seen at the end of phase 1, either the functional group is added or it is exposed. Now to this exposed functional group, we will add another endogenously derived substances such as glucuronic acid sulfate, glutathione amino acids, acetate, and make it more polar. So there will be highly polar inactive compounds which can be excreted rapidly in urine and feces. It can result in active conjugate as well. So at the end of phase 1 and phase 2, in phase 1 we have seen prodrugs they get activated after. At the end of phase 2, do all drugs get inactivated? Answer is no. Even at the end of phase 2 reaction, uh, some drug metabolites may be still active. For example, 6-glucuronide metabolite of morphine is more potent than the parent compound morphine. So the reactions involved in phase 2 are glucuronidation, sulfation, acetylation, methylation, and glutathionylation. So drugs which undergo glucuronidation are acetaminophen, morphine, oxazepam, sulfation or acetaminophen, steroids, methyl-dopa, acetylation of sulfonamides, isoniazid, dapsone, methylation or L-dopa, methyl-dopa, and captive urine, glutathionylation or adriamycin, fosfomycin, busulfan. So the source of this entire lecture is Goodman-Gilman, and if you want to do more reading, you can read from this textbook as well.